Hello viewers, welcome to my channel. I'm Hasham. So far 7 problems I have completed on transportation. So 2 stages are there. The first stage we have to find out the IBFS, initial basic feasible solution. Then we have to find out the optimum solution. For finding out IBFS, we apply VAM method, Vogel's approximation method, because this method is superior compared to northwest corner rule and least cost method. After finding out IBFS, most of the times IBFS itself will become optimum, or sometimes 1 or 2 tables are required to find out the optimum solution. So if you want the perfect knowledge on these transportation problems, watch all the videos from beginning till end. Starting first 3 videos, I have explained you about transportation problems. The next 3 videos, I have explained you all the problems, how to find out the IBFS and how to find out the optimum solution. Now, before starting the 8th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain every point in detail. Now, see problem number 8. Find out the minimum cost solution for the following transportation problem, which has cost structure from 3 rows are given and 3 columns are given. So we assume that in rows we have the origins and columns we have the destinations. So we give the names to the origins S1, S2, S3. And we give the name to the destinations D1, D2, D3. So from S1, S2, S3 to D1, D2, D3. The total availability from the origin are 14, 16, 12 units. And the demand at the destinations are requirement 10, 15, 17. If you add up 14, 16, 12, 42. Similarly 10, 15, 17, 42. The problem is balanced. The total demand and total supply are equal. And the costs are given. Unit cost, unit transportation cost. From S1 to D1, 16 rupees. From S1 to D2, 19 rupees. From S1 to D3, 12 rupees. So all the unit costs are given. Now, first of all, we need to find out the IBFS by VAM. Here, finding the IBFS by VAM. So the same table, O1, O2, O3, origin, and D1, D2, D3, destination. The unit cost I have taken on the upper right corner, 16, 22, 14, 19, 13, 28, 12, 19, 8. These are the unit cost of transport. And the supply from the origins are 14, 16, 12. And requirement at the destination, 10, 15, 17, total 72, right? Now 3 penalties, row penalties I have drawn 3 because the problem is very small problem. Only 3 rows, 3 columns. So I have taken approximately 3 penalties, but don't make it a rule. Sometimes we need 4 penalties, 5 penalties also, right? What do you mean by penalty? Penalty is the difference between the smallest cost and the next smallest cost in each row and each column. So we need the penalty for rows and penalty for columns. So first of all, in the first row the minimum is 12, next minimum is 16. So 16 minus 12 is 4. Here minimum is 13, next minimum is 19. So 19 minus 13 is 6. Here the minimum is 8, next minimum is 14. So 14 minus 8 you will get 6. So row penalties we have calculated. Now column penalties. First column minimum is 14. Next minimum is 16. 16 minus 14, 2. Here the minimum is 13. Next minimum is 19. So 19 minus 13, 6. Right? Next. Here the minimum is 8. Next minimum is 12. So 12 minus 8 is 4. That's all. Here, what is the highest penalty we have to select? The highest penalty is 6. But 6 is occurring how many times? 3 times. So whenever there is a tie in penalty, then compare the cost. Wherever we are having lower cost, that penalty will select. So if we select this 6, the lowest cost is 13. If we select this 6, the lowest cost is 13. If we select this 6, again lowest cost is 13. But if we select this 6, the lowest cost is 8. So compared to this 6 and this 6 is better because we are having a lower cost of 8. So we assign the maximum allocations in this cell. Row total is 12, column total is 17. Whichever is less, that can be allocated. So here 12 is less. So I have allocated 12. This will become 0. 17 minus 12 is 5. So whichever row or column has become 0, that should be blocked. Here row has become 0. So this O3 row will be blocked. This is the block of O3 row. Finished. Now we'll come to the second penalty. Second penalty. So 16 minus 12 is 4. Here 13, 19. 19 minus 13 is 6. Here dash because it is blocked. It is exhausted. So dash. Here column wise 16, 22. So 22 minus 16 is 6. Right? And 19 minus 13 is 6. Here 19 minus 12 is 7. Right? Now what is the highest penalty? 4, 6, 7, 6, 6. So 7 is the highest penalty, rounded off. Now find out in which column we are having this D3 column. What is the lowest cost here? 12. 12 is the lowest cost. So we will allocate here. The row total 14, column total 5, whichever is less. So we allocate 5. So 5 minus 5, 0. Here 14 minus 5 remains 9. Right? Now column is exhausted. Now we block the column. We have blocked the column D3. That's it. Now next penalty. The next penalty 19 minus 16 is 3. This is 22 minus 13. So 7, 8, 9. Here it is exhausted, blocked. Here 22 minus 16 is 6. 19 minus 13 is 6. This is dash. So third penalty, what is the highest penalty? 9 is the highest penalty. Rounded off this 9. In which row? O2 row. What is the lowest cost here? 13. Now allocate in the cell 13. Row total 16, column total 15. Whichever is less. So 15 is less. Here I allocate 15. 15 minus 15, 0. 16 minus 15, 1. So this column is exhausted. So block the column. Now, in any row or column, if only one unoccupied cell is there, we take the balancing figure. In the first row, you can see only one unoccupied cell is there. And the row total is 9. So we allocate 9 here. This will become 0. So 10 minus 9 is 1. Now how many cells are unoccupied? Only one cell is unoccupied. Where the row total is 1, column total is 1. So I am allocating 1 here. This will become 0 and this will become 0. That's all. All the allocations are completed. You can see either the cells are occupied or the cells are blocked. There is no left out cells. That means we have reached the solution. Number of allocations are 1, 2, 3, 4, 5. And m plus n minus 1. M means number of rows. N means number of columns. So we have 3 rows and 3 columns minus 1. So 3 plus 3, 6. 6 minus 1 is equal to 5. Now what is happening? After completing the allocations, you must see whether the number of allocations are equal to m plus n minus 1. If it is equal and all the allocations are independent, then we can say the solution is non-degenerate. The solution is feasible. Now we can proceed ahead to find out the optimum solution. If both are not equal, number of allocations and m plus n minus 1 is not equal, then the problem is called degeneracy problem. In that case, we have to use epsilon to overcome the degeneracy and then find out the optimum, right? So here, no need. M plus n minus 1 and is equal to number of allocations, and all the allocations are independent. There is no loop formed among all the allocations. We can say it is non-degenerate. Now we proceed to find out the optimum solution. To find out the optimum solution, we apply UI and VJ method. UI, first of all, copy down the same table and write the allocations. First cell 9 allocations. Then here 5 allocations. Then here 1 allocation. Here it is 15 allocations, right? And 12 allocations. Or these are the allocations already we got it here. One column and one row. The column is UI, U1, U2, U3. And the one row, VJ, V1, V2, V3. Other values are same, whatever we have done here, right? UI and VJ. Now arbitrarily we can take any U value as 0, either U1 or U2 or U3. So I have arbitrarily taken U1 is equal to 0. Now the other values of UI and VJ can be calculated by this equation, by this relation. Cij is equal to UI plus VJ. Cij means the cost of ith row and jth column, right? For occupied cells, these are the occupied cells. By using these occupied cells and applying in this relation, we can get the other values of UI and VJ. For example, this is the first cell. What is the location of this first cell? First row, first column, C11. This is called C11. What is the actual cost? C11, 16. So here C11 is equal to U1 plus V1. How much is C11? 16 is equal to U1. U1 already I have taken 0 plus V1. So 16 is equal to 0 plus V1, or we can say V1 is equal to 16. That's all. One value we got. Now we make use this cell. First row, third column, 1, 3. So C13 is equal to U1 plus V3, right? What is C13 here? 12. 12 is equal to U1. U1 is 0 plus V3. So 12 is equal to 0 plus V3, or we can say V3 is equal to 12. V3 is equal to 12, right? What is the location of this cell? Second row, first column, 2, 1, C21. So C21 is equal to U2 plus V1. How much is C21? 22. Is equal to U2. We don't have U2 plus V1. How much is V1 here? 16. V1 is 16. Take this 16 to LHS. This is not 0. U2 we have to find out. U2 we have to find out. V1 already we have 16. So take this 16 to LHS. So 22 minus 16 is 6. So we can take U2 is equal to 6. Here I have taken 6. Now I'll make use this cell to find out the value of V2. What is the location? 2, 2. C2, C22. So C22 is equal to U2 plus V2. What is C22 here? 13 is equal to U2. How much is U2? 6 plus V2. V2 we don't have. So this 6 take it to the LHS. So 13 minus 6 is 7. So V2 is equal to 7. We got V2 is equal to 7. Lastly, we'll make use this cell to find out U3. What is the location of this cell? Third row, third column, C33. So C33 is equal to U3 plus V3. How much is C33 here? 8 is equal to U3. U3 we don't have. Plus V3. V3 we have 12. So we can write 8 minus 12 is equal to U3. So U3 is equal to minus 4. U3 is minus 4. That's all. We got all the values of U1, U2, U3 and V1, V2, V3. Now the opportunity cost of unoccupied cells can be calculated. The final step is we have to find out what is the opportunity cost of the unoccupied cell. These are the unoccupied cells. 1, 2, 3, 4. These unoccupied cells, we have to find out the opportunity cost. How to find out? The formula is delta Ij is equal to Cij minus Ui plus Vj. This delta Ij is the opportunity cost. That's what we have to find out. What is the location of this unoccupied cell? First row, second column. First row, second column, delta 1, 2. So here delta 1, 2 is equal to C12. How much is C12 here? 19 minus U1, U1 is 0 plus V2, V2 is 7. So it is equal to 19 minus 7 is equal to 12. 19 minus 7 is equal to 12. So this 12 is delta 1, 2. Here I am writing 12. This is the opportunity cost. Right? Now next unoccupied cell is this. 2, 3. That means second row, third column. So delta 2, 3. So delta 2, 3 is equal to C23. How much is C23 here? 19 minus U1. Sorry, U2. U2. How much is U2 here? 6 plus V3. V3 is 12. So here 19 minus 18, that is equal to 1. 19 minus 18 is equal to 1. The opportunity cost is 1. That's it. Now we'll come to the next unoccupied cell. Third row, first column, delta 31. So delta 31 is equal to C31. How much is C31? 14. Minus U3. U3 is minus 4 plus V1. V1 is 16. That is equal to 14. 16 minus 4 is 12. So minus 12 is equal to 2. 14 minus 12 is 2. Next, this unoccupied cell. Third row, second column, delta 32. Delta 32 is equal to C32. How much? 28. Minus U3. U3 is minus 4. Plus V2. V2 is 7. That is equal to 28 minus 7 minus 4 is 3. So 28 minus 3 is 25. So this is 25. So we have calculated all the opportunity cost. According to optimality test, if all the opportunity costs are positive, we reached the optimum solution. If any one of the opportunity cost is negative, it is not optimum, some more modification, allocation we have to change. But here fortunately, you can see all the opportunity costs 12, 1, 2, 25. All the opportunity costs are positive. So we reached the optimum solution. This allocation is optimum, right? Since all the opportunity cost elements are positive, so optimum solution is reached. Now we'll find out what is the allocation and what is the total minimum cost. First allocation is O1 to D1. So O1 to D1. How many units? 9 units, 16 rupees. Then here O1 to D3. O1 to D3. How much? 5 units, 12 rupees. 5 units, 12 rupees. Then O2 to D1. O2 to D1. How many units? 1 unit, 22 rupees. 1 unit, 22. O2 to D2. O2 to D2. How many units? 15 units, 13 rupees. Last one, O3 D3. O3 D3. How many units? 12 units, 8 rupees. 12 units, 8 rupees. That's all. So we have made the allocations. Now we find out the cost. 9 into 16. 9 into 16 is equal to 144. Then 5 into 12. 5 into 12. It comes to 60. 1 into 22, 22. 15, 13. 15 into 13, it comes to 195. Then 12 into 8. 12 into 8 is 96. Now we add up all the cost. 144 plus 60 plus 22 plus 195 plus 96. It comes to 517. That's all. This is the minimum total transportation cost from this allocation. Now, if the business allocates in this way, the total cost will be 517. If they change the allocation, definitely the total cost will be more than 517. This is the minimum transportation cost. That's all. So in this video, only one problem I have explained, that 8th problem. So watch the video twice, thrice, and always keep a notebook, calculator, pen ready. Note down all the points which I am explaining, and it requires a lot of practice from your side. Only watching the video, listening the lecture does not be sufficient. It is not at all sufficient. You have to practice a lot in this type of problems. Inshallah, we will continue the next problem in the next video. So if you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, 9th problem will continue in the next video.